everyone. This video would focus on conic section, specifically on ellipse with center at HK, and this is the 9th part. In this part, we're supposed to determine the standard equation of an ellipse. We're supposed to sketch the graph of that ellipse. We are given the coordinates of the two foci and the eccentricity of an ellipse. Before we move farther with this example, let's have a review on the parts of every ellipse and the two cases of an ellipse with center at HK. Please remember that these are the parts of every ellipse. The first part is the center. For this case right here, this is not at the point of origin. Our center is at HK. This coordinate HK is the reading along the x-axis that is represented as the H, and the reading on the y-axis is represented as the K. Please remember that the center is the midpoint of the major axis. It's also the midpoint of the minor axis, and it's also the midpoint of the foci, the two foci. Another part is the major axis. The major axis is the longer diameter. This is the line segment that connects the two vertices passing through the center. So on both ends of the major axis is the vertex. A vertex is the endpoint of the major axis, and there are two of them. So we call them as vertices. Another part is the minor axis. The minor axis is a line segment that connects the two co-vertices passing through the center. So the endpoints of the minor axis is a co-vertex, and there's going to be two of them. We call them as the co-vertices. So by definition, a co-vertex is the endpoint of the minor axis. And again, there are two of them. Another part is the focus. We remember that the coordinate of the focus for this case, which is the horizontal ellipse, is represented as H plus minus C comma K. So this is the coordinate of the focus, again, for the horizontal ellipse. We remember that the distance from the center to the vertex is represented as letter A, while the distance from the center to the co-vertex is represented as letter B, and the distance from the center to the focus is represented as letter C. We also remember that the formula for a horizontal ellipse is represented as quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. Now, please notice that the value of a is under the quantity x minus h squared. The reason for this is because it is a horizontal ellipse. Horizontal means left and right, so the A will be under the X. Now, we also remember that the value for A is always greater than B. And the equation that relates A, B, and C is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. The second case of an ellipse is the vertical ellipse. We pretty much have the same parts. We have the center. We also have the major axis. We have the two vertices. We also have the minor axis. We have the two co-vertices. We also have the two foci. Now we remember that the coordinate for the focus of a horizontal ellipse is H comma K plus minus C. Now we also remember that the distance from the center to the vertex is represented as letter A. The distance from the center to the co-vertex is letter B. And the distance from the center to the focus is represented as letter C. Using all these values, we remember that the formula for vertical ellipse is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. Now we remember that our a squared, which is the greater value, is placed under quantity y minus k squared. The reason for that is it's because this is a vertical ellipse. We remember vertical, that means it's up or down. And so this is placed under the y. And we also remember that a is always greater than b. And the formula that relates these lengths A, B, and C is C squared equals A squared minus B squared. So these are the parts of every ellipse, and these are the two cases of every ellipse, the vertical and the horizontal ellipse. Okay, before moving further, let's have a review on the formula for the eccentricity of an ellipse. By definition, eccentricity of an ellipse refers to how flat or round the shape of the ellipse is. Mathematically, eccentricity is the ratio of the distance from the center to the foci, which we usually represent as letter C, and the distance from the center to the vertices, which we usually represent as letter A. Now, we remember that if eccentricity is equal to 0, then the conic section is a circle. On the other hand, if the eccentricity is greater than 0 or less than 1, we are able to come up with an ellipse. We also remember that if the E value is closer to 0, then the ellipse tends to be more circular in shape. On the other hand, if the E value is closer to 1, then it is more oval or elongated. Now let's look at the eccentricity formula of an ellipse. You will see the two cases of an ellipse, the horizontal and the vertical ellipse. Now we remember that the distance from the center all the way to the focus is represented as letter C, and the distance from the center to the vertex is represented as letter A. On the other hand, if we get a vertical ellipse, it's pretty much the same thing. The distance from the focus to the center is represented as letter C, and the distance from the vertex to the center is represented as letter A. Again, mathematically, eccentricity is the ratio of the distance from the center to the foci, which is represented as letter C, and the distance from the center to the vertices, represented as letter A. We can therefore write the equation of eccentricity as E is equal to C over A. So this is the formula for the eccentricity of an ellipse. Eccentricity is equal to C over A. Okay, going back to the problem right here, we are given the coordinates of the two foci. I'm going to change this 3 plus 2 squared root of 5 to its decimal version, and this 3 minus 2 squared root of 5 using the decimal version, and that is using the calculator. This would come out negative 3. This whole thing will come out 7.47. And then the other one right here is negative 3. Using the calculator, this would come out negative 1.47. So I am going to plot these 2 points on this Cartesian coordinate plane down here. So I plotted the two foci right here. Now we remember that the center of an ellipse is the midpoint between the two vertices, the midpoint between the two co-vertices, or the midpoint between the two foci. So using these two dots right here, we can tell that the center of this ellipse is located down here. So we can go ahead and count it. 1, 2, 3, 4. And so we have 1, 2, 3, 4. So this is our center. That's the midpoint between these two foci. From here, we can say that the center is on negative 3, 3. And this is an example of a vertical ellipse because the two foci are vertical relative to each other. So I'm going to go ahead and write that information up here. Okay, since this is a vertical ellipse, I'm going to write the general formula of every vertical ellipse down here. notice that the a squared, which is the bigger value, is placed under the y because again, that's a vertical ellipse. Now, looking at this, we don't have a value for b, we don't have a value for a, but we have a value for h and k because that represents the center of this ellipse. But in this problem, we are given the foci, the coordinates of the foci, and the eccentricity. Please remember that the distance from the center to the focus is represented as letter C. Now, looking at this coordinate of the foci, since this is a vertical ellipse, this coordinate right here actually stands for H, comma, K plus C, and this is H, comma, K minus C. So that we can go ahead and say that this plus 2 square root of 5 is the C, and at the same time, this minus 2 square root of 5 is our C. So that we can go ahead and write that down here. So our C is plus minus 2 square root of 5. This is the distance between these 2 points right here. So that we can go ahead and say that since we're given the eccentricity and the formula for eccentricity is E equals C over A, we can plug in the value for eccentricity and plug in the value for C and solve for A since we need that over here. So our eccentricity is square root of 5 over 3 equals the C value is 2 square root of 5 over A. From here, we can solve for A by cross multiplying these two and multiplying these two. So this would come out square root of 5a equals 6 because that's 3 times 2 is 6 square root of 5. We wanted the a, so we're going to divide both sides by square root of 5. Divide this by square root of 5. So we can cross that out. We are left with a is equal to 6. And this tells us that our a squared is 36 because we have 6 squared is 36. So this equation that we have here will come out x, since our h is negative 3, switch it so that it becomes x plus 3 squared over b squared. We don't have it. Plus, we have a y. And then our k is positive 3. Switch it so that becomes a negative 3 squared over our a squared is 36 equals 1. Now, we don't have the b squared. However, we can use the formula c squared equals a squared minus b squared to solve for b squared. So I'm going to go ahead and show that work down here. So our c is 2 square root of 5. So I plug it in. 2 square root of 5 squared equals our a squared is 36 minus b squared. So when we distribute this 2 squared, that becomes 4. And then distribute the square root of 5 squared is just 5. And that is equal to 36 minus b squared. So 4 times 5 is 20 equals 36 minus b squared. So we're going to add b squared from both sides and solve for b by itself. So our b squared is 16. So I will plug that in here, 16. And this is the equation for this problem that we have up here. Now, we remember that our b is the distance from the center to the co-vertex. So our co-vertex is left and right. Well, the a is the distance from the center to the vertex, which we go 6 up and 6 down. So I'm gonna go ahead and write the vertex here first. 1, 2, 3, 4, 5, 6. So this is the first vertex. 1, 2, 3, 4, 5, 6. This is the other vertex. Well, the b, we go left and right for 1, 2, 3, 4. And then that's the co-vertex. And 1, 2, 3, 4. This is the other co-vertex. And we are going to sketch the ellipse. So I will write the coordinates of the 2 vertices and the coordinates of the 2 co-vertices down here. So this is the equation for this problem right here, and this is the graph of this equation. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. So I'm going to change this 2 plus square root of 15 and this 2 minus square root of 15 to its decimal version. So I am going to plot these two foci on this Cartesian coordinate plane. Now we remember that the center of an ellipse is the midpoint between the two vertices, or the midpoint between the two co-vertices, or the midpoint between the two foci. So looking at this, we can go ahead and say that the center between these 2 points is this dot right here. So I'm going to go ahead and label this as the center. So we can go ahead and say that the center is on 2, -1. And looking at this, since the two foci right here are horizontally aligned with respect to each other, we can go ahead and say that this is an example of a horizontal ellipse. So I'm going to go ahead and write that information up here. So this is the general equation for every horizontal ellipse. The A is under the x squared. Now, in this problem, we are given the distance from the center to the focus, and that is actually represented as letter C. Now, please remember that for every horizontal ellipse, this coordinate of the foci is represented as h plus c comma k, h minus c comma k. So we can go ahead and say that our c is plus minus square root of 15. So this is our value for c. So I can go ahead and write that down here. So c is plus minus square root of 15. Or you can use the distance formula. You still get the value square root of 15. So we already have a value for C, but we wanted the A and B to come up with an equation of the ellipse. Now, we are given the eccentricity. And remember, the formula for eccentricity is C over A. So we can solve for A from here. We plug in the value for eccentricity and we plug in the value for C and solve for A. I'm going to show the work down here. So we already have a value for a squared, which is 64. So this equation would come out x, that's gonna be, since this is a positive 2, so it will come out -2 in the equation, squared over our a squared is 64, plus y, our k is a -1, so this comes out a plus 1 squared over b squared is missing equals 1. Remember that our a is the distance from the center to the vertex. So from here, I go 8 left and 8 right to determine the location of the vertex. Okay, now we need to determine the value for b squared to complete the equation. Now we remember that we can solve for b squared by using the equation c squared equals a squared minus b squared. So I'm going to show the work down here. So the value for b squared is 49. So I'm going to go ahead and write that up here. That is 49. So this is the equation of this word problem that we have up here. Now, we remember that the b is the distance from the center to the co-vertex. So that means I go up 7 and down 7. And those are the 2 points or the 2 coordinates of the co-vertices. So this is the graph of this equation of the ellipse down here. Now I'm going to write the coordinates of these 2 vertices and the coordinates of these 2 co-vertices down here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!